Welcome to a heat conduction in a rod example. So in this example, a 20 centimeter rod has both ends held at a constant 0 degrees Celsius. We'll let X be the position on the rod in centimeters from one end. The initial temperature in the rod is given by f of X equals X for 0 less than X less than or equal to 10. That should actually be 0 less than or equal to X less than or equal to 10. And 20 minus X for 10 less than X less than or equal to 20. If A equals 4, find the equation for the temperature in the rod at position X and at time t seconds. So our job here, the first thing we should do is just translate the problem into symbols. So we have a 20 centimeter rod. We are going from 0 to 20. This is our L is equal to 20. F of X is our initial condition, initial temperature. So we have U of X comma 0 is equal to F of X. We have both ends held at a constant 0. So this is U of 0t is equal to U of LT is equal to 0. So those are all the conditions that we are working on. Again, we have A equals 4. And so the problem becomes, the problem in symbols becomes, we have the partial with respect to t of u is equal to a squared, so 4 squared times the second partial with respect to x of u. This is for t greater than 0 and x between 0 and 20. We also have, again, u sub x 0. Actually, let's do the boundary conditions first. U of 0t is equal to U of LT, in this case, U of 20t, both of which are equal to 0 for t greater than 0. And we have U of x0 is our f of x for 0 less than or equal to x less than or equal to L, which again in this case is 20. So this is our problem in symbols. I'm just going to put in parentheses that our A is 4 and our L is 20, since those pop up in our solution. Our solution, we know, the sort of general formula, not plugging in any of the symbols yet, is that U of xt is equal to the sum from n equals 1 to infinity, e to the negative a n pi over L whole fraction squared t times sine of n pi over L x. Oh, sorry, I forgot my c sub n's. There should be a c sub n in front of the e to the negative. And our c sub n is equal to 2 over L times the definite integral from 0 to L of f of x times sine of n pi over Lx dx. So plugging in A equals 4 and L equals 20, we get U of xt is the sum from n equals 1 to infinity of c sub n times e to the negative 4n pi over 20 whole fraction squared t times sine of n pi over 20x. Of course, we could reduce our 4n pi over 20 if you wish, or you can leave it as is. Our c sub n is equal to 2 over 20 times the definite interval from 0 to 20 of f of x times sine of n pi over 20 x dx. But we do have our f, so this is equal to, so solving for Cn, solving for c sub n, we have c sub n is equal to 1 over 10 times the definite interval from 0 to 10 of f of x, which between 0 and 10, f of x was equal to x, times sine of n pi over 20 x dx. And then plus, we have 1 over 10 times the definite interval from 10 to 20 of f of x, which between 10 and 20, f of x was 20 minus x. We have a definite interval from 10 to 20 of 20 minus x times sine of n pi over 20 x dx. So we have two integrals to do. We can go ahead and run our rapid repeated integration by parts. So in one case, we'll set our u to be x and our dv to be sine of n pi over 20x. That's our first integral. So we are looking at u goes to 1 and then 0 as we differentiate. Sine of n pi over 20x goes to a negative 20 over n pi. Cosine of n pi over 20x for the first integral. Integrating again, we will have a negative 20 over n pi, the whole fraction squared, sine of n pi over 20x. We take the positive product on the first diagonal, negative product on the second diagonal. So we wind up with negative x times 20 over n pi, or negative 20 over n pi times x times cosine of n pi over 20x, and then plus 20 over n pi whole fraction squared times sine of n pi over 20x. That's the first integral, not yet taking the definite integral. And then for our second integral, we will set our u to be 20 minus x, our dv to be sine of n pi over 20x. Differentiating down the left side, that 20 minus x will go to negative 1, followed by 0. Sine of n pi over 20x again goes to negative 20 over n pi. Cosine of n pi over 20x for our first integral. Integrating again, we will get a negative 20 over n pi, entire fraction squared, sine of n pi over 20x. We take the positive product on the first diagonal, negative product on the second diagonal. So this integral becomes negative 20 over n pi times 20 minus x times cosine of n pi over 20x. Then we'll have minus 20 over n pi whole fraction squared, sine of n pi over 20x. So these are our two integrals. So putting these all back together, we have that Cn is equal to 1/10 times, we have a negative 20 over n pi x cosine n pi over 20x plus 20 over n pi squared sine of n pi over 20x. This is then being evaluated at 0 and 10. To that we will add 1/10 times negative 20 over n pi multiplying 20 minus x times cosine n pi over 20x minus 20 over n pi, the entire fraction squared, times sine of n pi over 20x. And again here, now we are evaluating at 10 and 20. So we have C sub n is equal to 1/10 times, plugging in 10 first, we would have a negative 200 over n pi times cosine of n pi over 2 plus 20 over n pi whole fraction squared times sine of n pi over 2. And from that, we would subtract off, plugging in 0 to that negative 20 over n pi x cosine, we wind up with 0. And then we're also subtracting off 20 over n pi squared sine of 0. So this is just that first definite integral. Then we have 1/10 times the second definite integral. So we have 1/10 times plugging in 20. That first piece would be a negative 20 over n pi times 0 times cosine of n pi. Then we would be subtracting off 20 over n pi, both things squared, times sine of n pi. From this, we will subtract off what happens when we plug in 10. So we will subtract off negative 20 over n pi times 20 minus 10 becomes a negative 200 over n pi times cosine of n pi over 2. And then from that, we are subtracting 20 over n pi whole things squared sine of n pi over 2x. So just some terms here will go straight to 0. Our term with sine of 0 will go to 0. Our term with a negative 20 over n pi times 0 cosine n pi will go to 0. Our sine of n pi term will go to 0. Of course, our 0 is 0. So we essentially have 4 terms remaining. We have C sub n is equal to, multiplying in our 1/10, we would have a negative 20 over n pi times cosine of n pi over 2. Plus we would have 20 squared divided by 10 would be 20 times 2 or 40 over n pi squared times sine of n pi over 2. Then we have 1/10 times a negative minus a negative, so 1/10 times positive 200 over n pi becomes a positive 20 over n pi cosine n pi over 2. And then we have again a subtracting a negative becomes positive 20 squared over n pi, or 20 over n pi squared times 1/10. That becomes plus 40 over n pi squared. The 40 is not being squared, times sine of n pi over 2. I apologize. The last line in my previous equals should have just been n pi over 2. There should have been no x. Right, at this point, that negative 20 over n pi cosine n pi over 2 and positive 20 over n pi cosine n pi over 2 just cancel each other out. And we wind up with an 80 over n pi whole n pi squared times sine of n pi over 2. Once again, we have our situations to play around with here. So if we look at our unit circle, sine is 0 at the, sine is 0 on the x-axis and 1 on the y-axis. So for n even, we're on the x-axis. So for n even, we get the sine of n pi over 2 is just 0. And so we get that our c sub n is 0 for n even. For n odd, those are the top and bottom of the unit circle. We'll go ahead and set n equal to 2k minus 1. Then we have sine of 2k minus 1 times pi over 2. This is going to be equal to positive 1 for k equals 1, because that will just be pi over 2. Negative 1 for k equals 2, and then it'll alternate. So this is equal to negative 1 to the k plus 1. Again, we just have to check for k equals 1. Then we are looking at sine of 2 minus 1 times pi over 2, which is sine of pi over 2, which is positive 1. And so we do want that k plus 1 to get the positive 1 out. And so what we get is that c sub n is equal to 0 if n is even, and it is equal to negative 1 to the k plus 1 times 80 over, in parentheses, n pi, close parentheses, squared. I'm going to actually swap that n out for a 2k minus 1. So 2k minus 1 times pi n parentheses squared for n equal to 2k minus 1. So putting this all together, we wind up getting that our our final solution would be that u of xt is equal to the sum from, I'm going to go from k equals 1 to infinity, we will have c sub n, so negative 1 to the k plus 1 times 80 over 2k minus 1 times pi, that entire denominator squared, times e to the negative a(n) pi over L was 4. N is now 2k minus 1 pi over 20. That whole thing squared times t. And then times, I didn't leave myself enough room, times sine of n pi over Lx. But again, our n here is 2k minus 1, and times pi all over 20, and times x inside our sine. So this is what we wind up getting as our solution. Again, I didn't really leave myself enough room. If I shift things just a little bit, I can maybe get it all in one row. So shifting things. Sort of. The exponent kind of wound up hovering over the sign. But as a general idea, you can kind of see what we wind up with as our final answer. So even being able to jump straight into the formula, there's still quite a bit of work finding those constants, particularly if our f of x is piecewise, if we need to do integration by parts. So again, we were able to jump straight to a formula, but there was still a reasonable amount of work left to do. In the next videos, we'll look at some alternative boundary conditions that we can have for our temperature in the rod, and how that impacts the formula we're working with.